Good evening, ladies and gentlemen. Can I encourage you to take your seats? And if you're looking for a seat, I can see that there's a number of seats down here in the front and against the wall there, in the middle over here. Don't be shy. We want you to be comfortable. You have a lot to learn tonight, and there will be a test. My name is Harvey Webster. I'm Chief Wildlife Officer and Museum Ambassador, and it's been my great privilege for the last 8 years to be host of the Explorer Lecture Series. And thank you for starting out the 2019-2020 Explorer Lecture Series with a sellout. Let's give it up. More about that in a second, but these are really amazing and exciting times for the Cleveland Museum of Natural History, and certainly what's been in the press over the last 3 weeks, Yohannes will be talking about tonight. But I hope many of you caught the coverage that Steve Litt did about the museum's plans for our transformation, this cool new building idea. We're kind of revolutionizing the transformation of the institution. We're utilizing local architects, DLR. We're invoking the whole metaphor of water in terms of its importance for life, water as the sculpting and shaping mechanism for the landscapes that we know, and DLR's come up with a cool design of the building that invokes that. So we're really, really excited about getting our next phases of the museum's transformation project underway. And there's tremendous excitement. For instance, if you go traveling down MLK and you see that cool banner right below the Perkins Wildlife Center that has our new vision statement: to explore, engage, and empower for a better tomorrow. Pretty cool, huh? We still have our same great mission statement: to inspire through science and education a passion for nature, the protection of natural diversity, fostering of health, and leadership to a sustainable future. But now we've got a really cool tagline that sort of captures the essence of who we are and the difference we want to make in the world. So speaking to that, there are some pretty amazing people in the audience that make this all possible. And one of the things that I'd like to do right now is recognize all of the directors. We used to call them trustees, but they got a job upgrade. All of the museum directors, if you're here in the audience, could you stand up so everybody could give you a round of applause and appreciate the leadership that you provide this fine institution? And then I'd also like to single out Sonia. Are you here? Are you here? Sonia Winter. There she is by the back door. You can see her. She's waving at you. Sonia is our president and CEO, and the energy that we have in the institution and the revitalization of our Centennial Transformation Plan are due extraordinarily to her. I mean, she's the one that has poked us and prodded us and gotten the right people at the table and the right kinds of consultations and gotten the board involved, and I think that we've got some really, really exciting plans moving forward. So these are great times for the museum, and I don't know if Denise Sue is around. Is Denise there? Denise is back there by Sonia. Denise is our Director of Programs and Partnerships, and she and Allison Brazia are the ones that have put together the Explorer Lecture Series for this year. So give it up for these fine people that make this happen for you guys. Now, it's so cool to say that I've got colleagues like Yohannes Haile-Selassie. I mean, it's just, I'm like a kid in a candy store because he is literally in a short list of some of the most preeminent paleoanthropologists of this or any other time. And it was kind of cool because in the spring, the American Association of Physical Anthropologists had their annual meeting in Cleveland. They decided to rock it out by the lake. And their hosts were none other than Yohannes and Denise Sue. And it was amazing to see 2,000 anthropologists from around the world all gather down at the Hilton downtown and pay homage to the excellence that's found right here in the city of Cleveland and right here at this museum. So a little bit about Yohannes. He is our curator and head of physical anthropology, and he's been here at the museum since 2002. He received his undergraduate degree in history from Addis Ababa University in Ethiopia, his master's in anthropology from the University of California at Berkeley, and his PhD in integrated biology, also from Berkeley. His main interest of research is Plio-Miocene mammalian evolution, with a focus on the origin of the earliest hominids and the evolutionary history of early Australopithecus. Over his career, Yohannes has discovered some of the most important hominid fossils known to science. Among these are the holotype of the 2.5 million-year-old Australopithecus garhi, the first pieces of the 4.4 million-year-old Ardipithecus ramidus partial skeleton, nicknamed Ardi. And by the way, in 2009, the American Association for the Advancement of Science declared that the description of Ardipithecus ramidus, which took an entire issue of Science magazine, was the scientific breakthrough of the year, of all scientific breakthroughs, of potential cures to cancer, of looking up in the cosmos. It was the significance of this find, and Yohannes found the first parts of that skeleton. He also found and named the 5.8 million-year-old Ardipithecus caraba. So this guy, during his time before he ever came to the museum, he was already a rock star. So it was appropriate that he come to Cleveland. Soon after, come on, go with me on this one, guys. I got to tell you, so Denise had asked me if my band, I do play in a little band on the side, we all have to have something to fall back on. And so if our band, Fat City, might play at the opening reception of the AAPA to 2,000 people, which we thought, well, this would be kind of cool. And our intent was to get Yohannes up on stage with, one of those iconic Stratocaster guitars and just lay into one of those power chords, sort of like Guns N' Roses, but we couldn't do it. Anyway, it was a nice thought. In 2004, Yohannes, I'm sure you'll hear much about this, but he established the Woranso-Mille Paleontological Research Project study in a sprawling swath of badlands near the Woranso and Mille rivers. And that serves as his research base. And every year he gets an international team of scientists and students and Afar tribesmen together who systematically search the area for fossil clues to human evolution. And over the period of time that they've been doing this since 2004, over 12,000 fossil specimens have been found, including more than 230 fossil hominid specimens. This is an amazing treasure trove of insight into a really key period of time from 3.2-ish to 4.1. And three of the things that he's discovered that are featured in our exhibit are Australopithecus diaremida, a brand new species of Australopithecine, which he described, Catanumu, which is Australopithecus afarensis, the same species as Lucy, only instead of being petite and diminutive, Catanumu was large and robust, a big guy. And this most curious thing, a hominin foot called the Bertelli foot, that's hominin, but it's got an opposable big toe, but it's a contemporary of Lucy. And of course, just this last month, he has rocked the world with the announcement of the discovery of a complete cranium of Australopithecus anamensis, and literally has put a face to that species and has come up with a fossil find that's on a par with Lucy herself. So it's yeah, give it up. So I like to tell people when I'm describing Yohannes that he's got more notches in his trowel than any other paleoanthropologist. I think that is actually true. He's got an amazing ability to find the fossils in the field, and he's got an amazing analytical ability to figure out where these things fit on the family tree. And more, it's so important that we know who we are as a species and where we came from, and the fact that we are all one species. And all of the discoveries that he comes up with helps inform who we are and where we came from. So I got to tell you, it is an amazing privilege and pleasure for me to welcome to the stage Dr. Yohannes Haile-Selassie.
Well, good evening, everyone. I should have asked the senior management to pick somebody else to introduce me instead of Harvey. But I really thank him for his generous introduction, and also thank him for going through half of my talk today. Boy. I got to say that this is probably the largest crowd that I've ever had for any of my talks in this auditorium. And I'm really humbled and pleased to see you all. And thank you for coming. And I hope I do justice to your presence here by giving you this satisfactory talk today. I know that you're all interested in hearing more about the recent discovery and publication in Nature, which is MRD. But as you can see from the title, it has two parts. First is the origins told from Afar, which is one area that I'm going to talk about probably for a third of my talk today. And then the second part is the hidden treasures of Woranso-Mille, which is where I'm going to concentrate more on. So when we talk about our origins, you've heard so many times that we go back in time to about 6 to 7 million years ago, which is time when our lineage split from the common ancestor we shared with chimpanzees. And since then, we've been evolving from things like Sahelanthropus chadensis about 6.5 million years ago to Ardipithecus cadabra at 5.8. And then you have Ornithoganensis from Kenya, and another species, Ardipithecus ramidus at 4.4, and then we get to the genus Australopithecus about 4.2 million years ago. So we've been trying to make sense out of all these fossils that we're finding in the field and try to connect the dots in terms of how did we end up being who we are today? What are the major morphological changes that happened, and what triggered those changes? Those are some of the fundamental questions that we have to address, but all of these questions can only be answered by finding fossils from ancient deposits like what I'm doing in the Woranso-Mille area, but people have been doing this since the 1920s. And of course, the idea of human origins and evolution goes back to before Charles Darwin, as you know. But we're privileged to actually have fossils to talk about, unlike Charles Darwin, who didn't have any fossils. But when he said humans must have originated in Africa, his thoughts were practically based on the similarities that he saw between the African apes, chimps and gorillas, and humans. He had no fossil evidence whatsoever to actually check what his hypothesis was, only to be tested after the 1920s with the discovery of some specimens from South Africa. But when we look at the provenience of all these fossils that we're talking about, they come from the specific area of Africa, particularly the East African rift system. Now, when we talk about the rift system, it extends all the way from the Afar region of Ethiopia. And you can see how wide the rift is right here, because this is an area where 3 different plates of the Earth are actually pulling apart from each other, like in different directions, right? And it gets really narrower as you go down. And when it gets to here, it bifurcates into 2 rift systems with the western branch on this side and the eastern branch on this side. And what's really interesting is all the fossils that we talk about when we talk about our evolutionary history, they come from all the way from here down, following the Rift Valley, down to about here. So when you look at that map overlaid on it, you can see that those sites where we have all these fossils correspond to the Rift Valley that I was talking about all the way down to here, except for some sites, particularly the South African ones, which are all cave sites. And none of them is older than 3 million years. So you can't really say much about the origin of humanity based on the fossils from South Africa, even though because the research on human origins started early on, like in the 1920s, the phrase cradle of humankind has been trademarked by South Africa. So no other country can use it, right? But again, when you look at the fossil record, obviously, there are other places who could actually be the cradle of humankind. So instead of saying the cradle of humankind, we use the cradle of humanity, which is not, it's almost the same, but you don't get into trouble with copyrights. But, so you look at this, and what was really surprising to us was that the earliest human ancestor that we recognize right now, Sahelanthropus chadensis, which is about 6 to 7 million years ago, we think, comes from outside the rift system, like in the Jurab Desert in Chad, which is way out here. So this is something that we really have to investigate in terms of how did it get there? And everything we have from about 6 million years all the way to the origin of anatomically modern Homo sapiens is recorded in Eastern Africa, but it just happens that the earliest homin that we have comes from outside the rift system. So that's one question to really address. And as you know, all of the apes live on the west side of this rift system, like chimpanzees and gorillas. And could it be possible that this was part of this diversity down here before hominids actually ventured out to this side of the rift system? So those are the kinds of questions that we really like to answer. But looking at this map, you can notice that there are so many species identified in the Afar desert of Ethiopia, including Lucy species of Ardipithecus afarensis, and so many more, right? So when we talk about what country is the cradle of humanity, you're going to have to think about what was found where, right? So when we look at the record from Ethiopia, you find that there are about 13 different species of early human ancestors identified from sites in Ethiopia, both in the Afar Rift and also in the southern Ethiopia region called the Omo Basin, which is an extension that goes down to Kenya, to all of the famous sites of Kenya. And most of what you have in Ethiopia, though, they're all located in the Afar region of Ethiopia, right? So what we don't have out of the list of 13 species, early homin species that you see here, there are only 2 that are not represented in the Afar region. Those are the species that represent what we call the robust lineage, which existed until about 1 million years ago, and they went extinct. So they don't have anything to do with our origins. They just survived, and they lived, and they went extinct. So when you combine all of the data from the Afar Rift, what you see is that there are hominins all the way from 6 million years ago to anatomically modern Homo sapiens at about 80,000 years ago, or even earlier, about 160,000 years ago, represented in this 1 kilometer thick sediments that sampled the last 6 million years. And no wonder why we have a zillion of projects going to the Afar region of Ethiopia, paleontological projects, looking for fossils. Now, work in the Afar started like in the early 1970s, and this is really what goes to the work of Donald Johanson, which Harvey mentioned earlier, in the early 1970s, and that really opened up a new venue to our understanding of human origins and evolution. And some of the discoveries from the early 1970s were like groundbreaking discoveries, which sort of reshaped our thinking about our evolution. So it's not only Ethiopia who has early human ancestor fossils. As I mentioned, Kenya has some sites. Tanzania has some sites. South Africa also has some sites. But just to give you a comparative look into what has come out of South Africa versus Kenya versus Ethiopia, this slide tells you a lot. So in South Africa, we have specimens that are dated as early as 3 million years, but none of them is older than 3 million years. When you look at the record from Kenya, they have a much wider sample all the way to 6 million years ago or slightly older, but it's really patchy. There are so many gaps in between those dots that you're seeing, right? When you go to the Ethiopian record, it's a totally different story. We have at least something from each time period that we can actually connect the dots and try to understand all the changes that have taken place throughout our evolutionary history in the last 7 million years. So Afar became like the place to go when it comes to human origins research, with the discovery of particularly our famous Lucy. Now, Lucy was found in 1974. 1974, before her discovery, the earliest human ancestors that we had known were about 2.5 to 2.8 million years old. So when Lucy was found, she became the earliest known human ancestor in the fossil record. Lucy became a rock star. And Don Johanson did a very good job, not only in making sure that people knew who Lucy was, especially when she is linked to the Beatles song, Lucy in the Sky with Diamonds. Lucy in the Sky with Diamonds. Yeah. Well, I'll tell you a story. I was doing an interview with this BBC radio like 4 days ago or so. So journalists are so mad that I didn't give a nickname to this new specimen, right? So he asked me, when they found Lucy in 1974, they were listening to the Beatles song "Lucy in the Sky with Diamonds," and that's why they called her Lucy. So how come you didn't give this guy a nickname? And my answer to him was, well, sorry, but I was not listening to any song at that time, so I couldn't give it a nickname. So journalists love nicknames. But Lucy became the icon of paleoanthropology simply because she was the oldest at that time, not anymore, but she was also a partial skeleton, the first partial skeleton ever discovered in the fossil record. And obviously, when she came here to the Cleveland Museum of Natural History, which is her first home away from home, and we're proud of that, she spent about 5 years here, and that's when researchers in paleoanthropology started pouring to this museum to have a glimpse of Lucy. And also in 1976, they found at Harar, the same site, what they called the first family, which was like a mix of like about 14 or 15 individuals in this little area. And that first family also attracted a lot of scientists to this museum, and they were doing all the comparative analyses, and all the debates were happening in this very museum in our lab. So she really opened a new venue to our understanding of human origins and evolution. Now, she's 3.2 million years old. She's not the oldest human ancestor anymore, but she is still the icon in paleoanthropology. People love talking about Lucy. Not a whole lot of people know about Ardi, or Kadanumu for that matter, but Lucy is like a household name. Then we have this fantastic discovery from 1994, a partial skeleton of Ardipithecus ramidus, a 4.4 million year old human ancestor. Now, this was really a surprise to a lot of us, because once we separated from the common ancestor we shared with chimpanzees, we didn't expect to see a foot that had opposable big toe, because we thought we already passed that stage. But Ardipithecus actually had opposable big toe on her feet. So this species was like 1 foot on the tree and 1 foot on the ground. That was really a surprise. And also this comes from the Afar, right? So giving us, again, another look at our origins and evolution. Then in 2001, I found and named this species Ardipithecus cadaba at about 5.8 million years ago. And this was, at that time, the earliest human ancestor known. So just imagine, you are a graduate student, and you're naming a new species, and you're publishing it in Nature all by yourself. So the kind of feeling that you get out of that is like, oh, well, this is really cool. What if I can have my own site and find more? And that has always been my wish, and that eventually happened. But at that time, all I wanted to do was find my own site, find the fossils, describe them, and publish them in journals like Nature and Science. And that's what I'm going to talk about a little later. But Ardipithecus cadabra was also a major discovery from the Afar. So if you follow all the time period that I'm talking about, we went from 3.2 all the way to 5.8 million years ago. And that's like a good chunk of our early evolutionary history that is all documented in the Afar Rift of Ethiopia. And as a matter of fact, Ardipithecus ramidus and Ardipithecus cadabra are only known from the Afar Rift. They're not known from anywhere else. The other thing that is really fascinating about the Afar is we also have the earliest documented stone tools at about 2.6 million years ago. This is from a site called Gona. And the red stars actually show the location of these sites. And you probably heard that there is now new evidence of stone tools from about 3.3 million years ago from a place called Lomekwi in Kenya. Now, it's not a surprise if they were making tools as early as 3.3 million years ago, but some scientists have doubts about how it was dated, and that's still controversial. But this stone tools from the Afar Rift from Gona remain to be like the earliest well-documented stone tools in the history of human evolution. And more recently, we have at 2.8 million years ago from this new site known as Lady Gararu. This is about 7 or 8 years old now in terms of when they started research in this region. And they found this half mandible, which they assigned to early Homo. Now, the earliest record of Homo we had before the discovery of this mandible was about 2.4, 2.3 million years ago. And some specimens are from Ethiopia, some others are from Kenya. But now this pushes back the origin of our genus Homo to about 2.8 million years ago. Now, that brings us to the question of whether we could actually expect to find the earliest members of our genus even before 2.8, which is kind of interesting. And that's one of the areas that I'm pursuing now. But we have not only the earliest record of human ancestry, but also the very first origin of our genus Homo from this Afar region. So all of the specimens that I talked about come from sites that are shown in this yellow rectangle: Lady Gararu, Harar, Gona, and mostly Middle Awash. So Middle Awash is really a rich site, and that's one of the localities, the sites that has all of the 1 kilometer thick deposits that I mentioned earlier, and they've been working there since 1981, and they've been finding a lot of fossils to explain our evolutionary history in the last 6 million years. So now, after I graduated in 2001 and I came here in 2002, as I said, I was as a graduate student, I was working with another project, and I always wanted to have my own project. So I didn't want to be called just the fossil hunter. Oh, he's got good eyes for fossils, and you find the fossils, but you don't happen to describe them, right? And that's not what I really wanted to continue in my career. So I really wanted to find a site of my own outside what has already been known. So we extended the survey further to the north to areas where people haven't, had any projects yet. And Woranso-Mille is actually a site that I ended up finding after like 3 years of survey further to the north, which is not shown in this map. But it took us 3 years of survey twice a year before we ended up at Woranso-Mille. Now, those first 3 years were really rough because it was usually me, one local Afar guide, and one camel to carry all my water. Yeah, that's all you can do as a fresh graduate student, but as a fresh PhD. But on the third year of our survey was when we found Woranso-Mille. And when we landed at Woranso-Mille, when I saw some fossils, obviously I saw some elements, and I realized that what we had was something older than 3 million years. Now, you can ask me how I knew that, And I'll tell you that there are some animals that we know whose evolutionary history is well documented, and the specimens that I saw of, especially like suids, which are pigs, are species that have gone extinct after 3 million years. What that means is if you have those, obviously the sediments that you're dealing with are older than 3 million years. So that was like my initial analysis of what I saw. But I didn't realize how significant this site was going to be. All I needed was like to find a few hominins. If I find some, get some papers out of it, it will be good for my career. But what happened in what's happening now is beyond what I expected when I started working at Woranso-Mille. So that work has been going on since 2005, and I'm not going to go through the 230-some hominin fossils that we have found so far from the site, but I'm going to give you a highlight of some of the major discoveries from Woranso-Mille and then lead to the discovery of the new specimen that I'm going to talk about in detail. So the first specimen of our first field season in 2005 that ended up to be really significant was this partial skeleton, which we nicknamed Kadanumwan, like this new specimen, which we didn't nickname. And this specimen was not only 400,000 years older than Lucy, but it was also the specimen that, for the first time, gave us a good understanding of the shoulder anatomy of Auditorium afarensis. All we knew about that species' shoulder anatomy before that was based on Lucy's tiny bit of scapula, or the shoulder blade, that was recovered with Lucy. So we learned a lot about the shoulder anatomy of Auditorium afarensis from the species. At the same time, we also had like a glimpse of how big members of her species could be, because as Harvey mentioned, Lucy was so tiny. She was such an odd individual in that species. She was so tiny, and you have individuals like Kadanum who are like 5'2", 5'3". So there is a huge range of variation, which they've documented from the first family, but this was a good specimen to actually give us a better idea from a partial skeleton. And the other thing that we learned from this specimen was the shape of the rib cage. Now, in the 1980s, when they reconstructed Lucy's rib cage, they were thinking about chimpanzee-like rib cage. So they made it like funnel-shaped. And there has been a lot of back and forth between scientists, like it shouldn't be barrel-shaped because on the human lineage, it should be like, like humans and so forth. But those ribs that you see on this slide actually helped us redo the rib cage of Lucy, which is what we have on the new reconstruction that you see outside. So it has a very significant contribution to our knowledge of that species, Auditorium afarensis. The other important specimen that we found, or specimens to which Auditorium deiromeda belong to, are these two upper and lower jaws and a few more specimens that we assigned to a new species. Now, these are the times when scientists are arguing about whether there were multiple species living at the same time during the Middle Pliocene, particularly between 3.3 and 3.5 million years ago. They had found at that time one species from Chad, which they called Auditorium garhi, Auditorium bahar-ghazali, and then another species from Kenya, known as Kenyanthropus palladius. Those are all between 3.3 and 3.5. But people had issues accepting those as valid species, and they were dismissing them as geographic variants of Lucy's species, Auditorium afarensis. Then we came up with this Auditorium deiromeda. Well, it faced the same fate. Our colleagues said, this is probably just Auditorium afarensis. But then we showed them, but we have this partial foot, which doesn't look like Auditorium afarensis foot, right? This is from the same time period as Auditorium deiromeda, from the same locality, well, nearby, but slightly younger in terms of its geological age. And none of our colleagues would actually put this partial foot into Auditorium afarensis. Because if they do, that means Australopithecus afarensis was not responsible for the footprints at Laetoli, which are 3.6 million years old. We all agree that the footprints at Laetoli were made by individuals of Australopithecus afarensis. But this foot wouldn't have made those footprints. What that means is we have yet another species living at the same time. And in the case of Woranso-Mille, in close geographic proximity, because this foot was found about, I would say, 2 kilometers away from where we have Australopithecus afarensis remains. So that was the conclusive evidence for the presence of multiple early human ancestors at the same time and in close geographic proximity. So this was really an important discovery that we've made from Woranso-Mille. And finally, I'm going to go to the one that you want to hear more about. MRD VP1/1. Now, this cranium, for a lot of our colleagues, it's going to become probably as iconic as Lucy, and there is good reason to say that. And I'm really happy to share with you like the entire story behind its discovery and how we did the interpretation to actually assign it to Lucy's ancestor, Australopithecus anamensis. Now, it all started with this local guy, Ali Barreno, finding the upper jaw, which is shown here. I will show you like a close-up of that on the next slide. And the only reason why he thought that this would be something that the doctor would like is because the teeth that are exposed on the surface look like his own teeth. And he knows that I'm looking for teeth that look like human teeth, right? And this guy has been trying to get hired by our project for like many years. And the only reason why he was at this place, which is not even his area, but of course, Afars, they can go anywhere in the Afar land and, build their tukul, no problem. Nobody's going to chase them away. So this guy happened to be in this specific area because during the rainy season, which is usually 1 or 2 days rain, and where he was flooded. So they usually move to higher ground when their area is flooded, and he ended up in this region, which I wouldn't even consider as potentially fossiliferous. We've been like in the vicinity, but we never made it to this specific locality. So as he was digging a hole for his newborn goats, because they have to hide them in a little hole and then fence it with thorns so that jackals or hyenas don't get them, right? So he was digging this hole when he saw that specimen. And we were across from where he was by about 4 miles to the southeast. And he knows, the Afars, the way they communicate is really amazing. The way news go from one place to another, the speed, it's really amazing. And he already knew that we were working at a nearby locality called Amado. So he calls Habib, who's like the chairman who always works with us, and he tells him, I think I have something that the doctoral might be interested in. So I've been fooled so many times, right? Especially if they live too far away and they need a ride. They come and tell me, oh, doctor, there is this moya means head. There is this head of like human-like thing, and I want to take you and show it to you. You can imagine how anxious I get when they tell me those kinds of things, because it could be true, right? So I said, come on, hop in. And they go back of the car, and we ride, and we get there, and I go like, where is it? And they go like, it was here. I don't know where it went. Yeah, they got there right? So I've been tricked so many times like that. So I said, you know what? I'm not going to go. Do you have anything? He said, yes. So I sent Habib to go with him back to the place where he said he found it. And Habib went. It was 45 minutes hike. It was like about 3.5 miles away from where we were. And they came back after like an hour and a half. And he had it like in his hand like this with the teeth like visible on top. And I was working on something, and I get up and I look at it. I didn't even take it from his hands. I said, "Where did you find it?" Usually, you don't want to show them your excitement when they find fossils, because they'll start picking up stuff. Because I always tell them, if you pick up a fossil from the ground, it's useless. I'm not going to even have a look at it, right? So I didn't want this guy to be so excited. I knew it was a hump, but I just wanted to go back to where he found it so that he can put it where he found it so that we can look for other pieces, right? That's how we do it. So I told the rest of the crew, okay, I'll be back in about half hour, because I know it's like a long way, but I had to tell them that, and I left with those guys. So we went back, and he showed me where he found it, and surprisingly enough, he didn't even destroy the print from where he lifted up the specimen. So when I told him to put it back, he put it back exactly the way he saw it, and it fit into the little hole where he found it, which is a good sign. Which means if there are any pieces, broken pieces from that piece, we'll find it, in the vicinity, right? But it was like in about 30 seconds, I turned around and this bulbous thing is like sitting there. And I'm like, what? Yeah. So the only guys who were with me were the chairman and the guy who found the maxilla. So I guess I started jumping up and down, and I speak their language, so the local guy tells Habib, the chairman, "Is the doctor going crazy?" And I'm like, no, I had to tell him in his language, "I'm not going crazy, So he thought, oh, I thought that was a rock. Okay, that's a rock. But that once I saw those two pieces, my hope was that those two pieces joined, because that was very significant in terms of how we would interpret that specimen. Because there were occasions where we had the cranium without the face, and then you find the face, but they don't join. So what that means is when you put those two together, depending on how you orient the face on the head, you can make it either more prognatic or protruding further, or you can make it more flatter. So I was just hoping that that doesn't happen to me, because that would be very bad. So I picked up both specimens, and click, it was like a perfect fit, all the way from the nose all the way to the back of the head. That was such an amazing moment that I can't even explain how I felt about finding it. The only thing that I was thinking about was like, well, it doesn't look like afarensis, because I've seen so many afarensis crania, but this is not something that I have seen before. But at the same time, I didn't know how old it was. All I knew was that it's older than 3.5 million years, but it could be 4.4 million years, it could be 4 million years, who knows? But it was something different. And I knew that this was going to make some, major difference in our understanding of our evolution between 3.5 and 4 million years ago. Now, when you find specimens, this is like the complete cranium that you can't run away. Even if you find like a tooth fragment, you're going to have to look for fragments of the same thing, and you have to sieve and pick through the sift and all that. So the place where he found it was, interestingly, next to where he's been keeping his goats for many months. And they've been sleeping and doing whatever they have to do, same place. So to just guide you, so this is where he found the maxilla, right here. You see that hole? That's the hole that he dug, but we had to remove all the thorns and stuff like that to do our sieving operation, right? And here is the head. So that's about 9 feet, about 9 feet, no, not 3, 9 feet. And when you have specimens like this, you're going to have to think about, how did these two specimens actually get there? you got to start thinking about like, okay, if it probably started from somewhere here and got trampled, it could go to different directions, right? So we had to decide like what area do we have to sift, like to see if there are like more pieces. Because when I looked at the head, there were parts missing that are really, really critical to the interpretation of that specimen. Because when we found the two pieces, it lacked the orbit, the margin of the orbit. And if we don't have the margin of the orbit, it's really difficult to reconstruct the whole face. We wouldn't have been able to see the face that we're seeing now, right? So we had no choice but to limit ourselves into a larger area to sift and look for fragments that might fit into the orbit. One side was already gone. We can tell because it was like an old break, and the break itself was filled with manganese, which tells you that it was not fresh break. It's not something that broke like in the vicinity. It's been broken for a long time. But the other side was fresh break. So that's what gave us hope that we will probably find the remains here. So this was a huge operation. And the major target area was this, right here, where the goats have been living for 3 months. Yeah. So the first thing that we had to do was actually to scrape the whole surface. Because they've been living here for a while. You can see how the goat droppings are like packed into the ground. So we had to use like, hammers like that to actually remove it so that we can get to the original surface. And then, because any piece could have been buried like in this goat dropping pile, right? So after we collected all of it, the next step was really amazing. So that pile there is not the usual kind of dirt that we usually sift, but there was no way to run away from it, right? But I love this slide. When you look at all the faces, look at them. They're all happy. All of them are happy, even though they know that they're going to sieve the hell out of goat droppings, right? This is what I call dedication to what you do, right? They were not even smelling it, It just didn't even smell like anything. But we had to do this for 3 days, and everything had to be sifted. And then we had to pile up all the sift that we did for like 3 days, and then pick the whole thing. So you can imagine all of these guys are local guys, right? And they help us a lot, not only in doing those kinds of things, but also in actually finding fossils, like what we talk about, like what I'm doing today. So all of that sifted material had to be picked. And again, this is Afar. And this is about 11:30. And there was only one small tree that we could get shade out of. So you can see everybody is like under it. 115. And you're sitting like a few inches away from this. The heat is kind of boiling it, right? And you can imagine, in case it's not really clear what that is, I can show you like a close-up of that. That's what we've been picking for 3 days in a row, right? Day after day after day. But everybody was happy to do it because they knew the significance of what we had. And they knew how significant it would be to find that missing orbit, right? I was like, we got to find this. If we don't find it, then this is nothing, We can't tell what it looked like. Of course, that's like my encouragement. But it's because of all this hard work and sifting through this pile of goat dropping that nobody would want to touch that we were able to convert something like this that we initially found in 2 pieces to something like this. Now it's got an eye socket, right? What that means is if you have one side, you can mirror image the other side, particularly with the technologies that we have today. I mean, I'll tell you a little bit about what we did with the CT scanning, but this is what we had in the end. And what's really interesting is from all the sifting operation, we were able to find 4 critical pieces that are shown here. Those were found in 4 pieces. They joined perfectly, and they joined to the rest of the cranium. It's because of this discoveries that we were eventually able to come up with the 3D reconstruction, which looks like this. Because once you have the CT scan data, you can mirror image those missing parts and make it as complete. But think about this. If we didn't have that orbit, then we wouldn't have been able to do this. Because we know that the orbit shape in various taxa of early human ancestors is different. Some of them have like right-angled corner. Some others have more rounded corner. So if we didn't have this, we wouldn't have known what that shape was. So that's why it was really, really interesting. But now that you have such a complete specimen, and you don't know how old it is. So that's the work of the geologist. This is something that you always try to figure out, because if you have such an important specimen, you want to know how old it is, right? So question is, how old is MRD? Now, because we've been working in this area for 15 years, at that time, actually 12 years, we've had good understanding of the geology, the overall geology, and we've identified all of the major marker horizons, and we had a number of tuffs already dated radiometrically, right? So when we got there, the geologists had actually identified some of the major tuffs that we've identified from other areas in the Woranso-Mille area. And you see that purple? That's like one of our major marker tuffs known as the Mille tuff. And it's been dated to 3.76 million years, almost 3.8, right? Now, we have a minimum age, right? Because the specimen comes right from down here, from the delta deposits here. So MLT, the Mille tuff, is above it by about 10 meters or so. Now, we have a minimum age, but what about maximum age? That was the big challenge for the geologist. And even though the maximum age could not be determined from where we found the specimen, laterally going to similar deposits and similar sections, they were able to find a section where the MLT is exposed at the top, and going down the sequence, they found a few tuffs below the delta deposits. They sampled that, they took it back to they brought it back, I thought I was speaking in Ethiopia. They brought it to the United States, and they dated it to about 3.82. Now we have minimum and maximum age. So that's based on that we determined that the minimum age is about 3.76, and maximum age is about 3.82. So doing like depositional calculations and the paleomagnetic polarity, we decided that this is close to about 3.8 million years. Now we know how old it is. The next question is, what is it, right? So 3.8 million year old complete cranium. Well, what species does it belong to? The choices that we had readily available are 2 species. One is Lucy species Australopithecus afarensis, which we know existed from 3 million years all the way to 3.6 million years ago. And the other one is Australopithecus anamensis, which we know survived from about 4.2 to 3.9 million years ago. So since this specimen is about 3.8 million years old, those would be like our first choices to associate it with, right? But before we got into the descriptive analysis, we wanted to make sure that we were equipped with all of the data that we can extract from the specimen. So the first thing that we did is, actually this was in 2016, 2 months after we found it, I had to export it from Ethiopia for micro-CT scanning. And I took it to Penn State. I have a collaborator and a colleague there, Tim Ryan, who was also one of the co-authors of the paper, and we got it CT scanned. So by CT scanning it, we were not only able to reconstruct the whole cranium, but we also had access to the internal anatomy of the cranium. And what you're seeing here is like section by section, and you can actually see the edges of the cranial bone, like that dark line that you see is separating the matrix field inside from the bones, right? And you can see all the sinuses inside and everything, all the details that you want to know about this specimen. And this is something that we couldn't do 25, 30 years ago. And it's because of the CT scan that we were able to finally look at what does it look like if it were complete, if it were not missing the right orbit, or if it were not missing, if it didn't have a crack at the base. And by correcting all this missing parts, we were able to finally see something that we can actually carry and compare with all the other crania that we have known, not only from Australopithecus afarensis and later hominins, but also from the earlier hominins like Sahelanthropus chadensis and Ardipithecus ramidus and so forth. So with that, we traveled not only to Ethiopia where the original specimen is kept, but we also had to travel to Kenya, Tanzania, South Africa to do the comparative analysis. And when we compared it to Australopithecus afarensis, I mean, even without me saying a lot, just look at the differences between Australopithecus afarensis, Lucy species. Look at the midface. It's really flat, right? Whereas MRD has very protruding midface. And you look at this earlier hominins, such as Sahelanthropus chadensis and Ardipithecus ramidus, they have that feature. So Ardipithecus MRD has some primitive features that are shared with this early human ancestors before 4 million years ago. But at the same time, you see that's Africanus from South Africa. This is only about 2.5 to 2 million years old. And that shape looks very much like what you're seeing in MRD. So this is a specimen that combines features that are primitive, like those guys here, and derived characters like those guys here. But since our purpose was to compare it with Australopithecus afarensis, we can distinguish it really easily, not just based on what we're seeing in the face, but also other features, like what you're seeing in the lower one, which is the back. You're looking at the back of the head. And this is one of the most complete specimens of Australopithecus afarensis, right? And you can see the difference between MRD and Australopithecus afarensis. And this is a chimpanzee. So you can see how primitive looking the base of the cranium is, right? It's more like chimpanzee than it is like Australopithecus afarensis. So it's really amazing how you have like primitive features, but at the same time some derived features in the same individual. So that's why in the papers we said this specimen has a mosaic of features, some of which are primitive, some of which are derived. And we used it to say that this is something that is like, that tells us that the specimen connects the primitive ones with the derived ones. That was one of our conclusions. So we had enough evidence to distinguish it from Australopithecus afarensis. By the way, I've been publishing papers on the specimens from Woranso-Mille that are dated to between 3.6 and 3.8 million years ago. And I've had issues like distinguishing those specimens either as Australopithecus anamensis or Australopithecus afarensis. They always are a mix of things like that are shared with anamensis and afarensis. And at a certain point I said, if we have like those specimens that are sharing the same things with both Australopithecus afarensis and Australopithecus anamensis, why are we recognizing them as two different species? Why don't we just put them into one species? That has always been my argument. But with this specimen, not anymore. Because now I realize how anamensis is different from Australopithecus afarensis, and we have to really restudy all the isolated teeth that we have from Woranso-Mille and make sure that they're assigned to the right species, whether they are anamensis or afarensis. So what did we have to compare with Australopithecus anamensis? This was one of our limitations because Australopithecus anamensis has been known since 1995. But all we know about Australopithecus anamensis is based on isolated teeth and things like what you're seeing here. A little fragment of the ear region, an upper jaw, some mandibles, lower mandibles. This is all we know. And this is what we had to compare with MRD. So it's so limited, right? But there were really critical elements of what is preserved of Australopithecus anamensis that helped us compare anamensis with MRD. And the canine stands as one of the most important elements of MRD and also Australopithecus anamensis. And we see that these early human ancestors, starting with Ardipithecus, Australopithecus anamensis, and back to Sahelanthropus chadensis, they had large canines. Their canines have not reduced to become more like an incisor. So what you're seeing in this graph is actually a reflection of that, where anamensis is plotting with larger canines compared to even Ardipithecus ramidus and also Australopithecus afarensis. That's a clear distinction. And here is MRD. So it had huge canine. And that's one of the reasons why we had to assign it as a male, in addition to the presence of a sagittal crest in the middle of its head. But we also looked at detailed morphological features of the canine. Now, the evolutionary process of these canines from the early forms to modern humans is that the canines get smaller in size, but also they become like incisors. So instead of those pointy dagger-like canines, they become more like our front teeth. And they get incorporated functionally with the incisors instead of a separate thing. So when you look at this slide, you can clearly see that anamensis canine has already started going on the way to becoming more like an incisor with this very vertical mesial face. And you look at the anamensis specimens, they have this shape that is still more like pointy, cone-shaped. And this was the most interesting specimen of Australopithecus anamensis from Kenya, which is almost a mirror image of what we have for MRD. So those were strong characters that actually helped us to distinguish, to recognize MRD as Australopithecus anamensis. So based on that was what we published in 2 articles in Nature online on August 28th. And those papers came out in the print version yesterday. Now that's the cover. Well, we didn't get the cover. We were hoping that we will get the cover, but we did get a mention on the front cover. Head start of a hominin. So yeah, but again, this was one of the interesting scientific stories for almost 2 weeks since its publication online. But what are the major points that we learned from MRD? Now, I mentioned that it has a mosaic of features, some of which are primitive, some of which are derived. So it serves as a bridge connecting those earlier forms of early human ancestors with the later forms. And one thing that is more like the derived forms like afarensis is the shape of the face. Now, what is happening here is our face gets broader. It gets wider than compared to the earlier human ancestors. So you see that trait already in Australopithecus anamensis and Australopithecus afarensis. But we also see very primitive characters like very narrow area behind the orbits, very long cranium, which is more like Sahelanthropus at 6 million years. So it has a mix of features, and that's something that we could claim as MRD connecting the primitive forms with the derived forms because it has a mosaic of features. But in terms of the phylogenetic relationships, we also try to test whether MRD actually puts anamensis as the ancestor of Australopithecus afarensis. Previously, based on all these dental remains and maxillary remains and mandibular remains, this was how we had the relationship. And you can see anamensis is right before Australopithecus afarensis as its ancestor. Now what we did was, instead of putting MRD into anamensis and treating it as a whole, we treated MRD, the specimen, as a species, Australopithecus anamensis, and did the same analysis. And what we got was the same thing. MRD plots exactly where anamensis should be. So that's additional evidence that our assignment of MRD into Australopithecus anamensis was correct. Now, the other thing that we concluded from this discovery is the overlap between the ancestor and descendant. This was one of the areas that some of our colleagues had issues. Now, previously, we've thought that anamensis gave rise to Australopithecus afarensis in a linear manner. But now, there is evidence to show that they actually overlapped for about 100,000 years. And what's the evidence for this? Because what we have is like 3.8 million years old. And most of the afarensis specimens that we know are younger than 3.6. But there was one specimen that was found in 1981 from Middle Awash in the Afar region. That 3.9 million year old specimen, nobody had ever put it into any specific species. So because what was known at that time was only Australopithecus afarensis, they referred to it as maybe it's afarensis, right? Then when Australopithecus anamensis was found, they said, well, maybe it's Australopithecus anamensis because of its age. Now, we did a comparative analysis, and that frontal, it's not that big, but it has a lot of morphological features. And when you overlap it to Lucy's species Australopithecus afarensis cranium, L444-2, it's a perfect match in terms of the breadth of the post-orbital area. And it is very different from what we're seeing in MRD. MRD is really constricted behind the orbits. And it's really long cranium compared to Australopithecus afarensis. So we said, this frontal that is 3.9 million years old should belong to Australopithecus afarensis. So we put it into afarensis, which means the age range for afarensis goes all the way back to 3.9 million years. And with Australopithecus anamensis present at 3.8 in the form of MRD, then there is clear overlap of at least about 100,000 years, and that could be expanded all the way to 3.7 because of some of the specimens that we have. Now, the question that comes to mind in this situation is, how is that possible that an ancestor and descendant could actually coexist? How is it possible? So I'm going to answer that question before you ask it. Now, we're talking about the East African rift system, where a lot of things happen driven by tectonics, right? So one good explanation that I can give you has to do with rifting, right? You look at this. This has been happening for millions of years in the East African rift system. Now, if you have a population that lived in this landscape, on this landscape, and all of a sudden this happens, which was quite often in the Afar, in addition to active volcanics like what you're seeing in the background here, right? So these people here are separated from these guys here, right? So they're going to adapt to that part of the environment. These guys are going to adapt to this part of the environment. And through time, in their efforts to adapt to this new environment, they're going to accumulate changes. And those changes accumulate through time and become enough to distinguish them from the population they started. This is what we call allopatric speciation, right? But the ancestor is still there, right? Those guys on the other side might evolve into something else, which is the case that could explain the overlap between Australopithecus anamensis and Australopithecus afarensis. So those were like the main conclusions that we had from the papers. But because it's really complete, this was the first opportunity to have a look at the face of Australopithecus anamensis, which is a species that we could actually connect as our ancestor. Because the earlier forms, such as Ardipithecus ramidus, Sahelanthropus chadensis, and Ardipithecus cadabra, for that matter, we may have issues to connect with them that much, because Ardipithecus ramidus, with opposable big toe, it's really harder to connect with than Australopithecus anamensis. But we have to see what it looks like, right? So we decided, okay, we know there is a good paleoartist who can do this job. Let's give him the task, and let's see what his reconstruction would look like. But of course, this is all because of the CT scan data that we had, right? So we started from what you're seeing on the left side. From here, this is the 100% reconstruction, and thanks to technology, that's the 3D print. Easy. So good transformation. So this is what I gave to John Gurche. Now, John Gurche has been doing this for more than 3 decades. And if you look at the Lucy reconstruction that we have outside, it was John Gertrude who did that one. So I gave him this specimen. Of course, like every other paleoanthropologist, even though he's a paleoartist, he was like, how old is it? I said, I don't know. What species does it belong to? I don't know. Blind test. Just use your anatomical knowledge. Look at the bumps and this and that, and just do your job. That's how he did it. But in the end, when he finished it, he said, this looks a little bit more primitive than Anamensis. This is long before the papers were published. So he was really good, and I'm really happy with his reconstruction. So what he did was he put a known Australopithecus anamensis mandible to it, after I told him that this was Anamensis. And he meticulously put all of the muscles of the face and the head on the specimen, like one muscle fiber at a time. And he came up with a flesh reconstruction that looked like this, which he eventually turned into this. Now, this is like the short version. But let me show you like a short clip of how he did it. And now watch this. And this guy, he is really detail-oriented. So he does everything like step by step. And I was following through all of this. And eventually, I was really happy to see like the final product. But the detail that he uses to reconstruct those kinds of things is really amazing. One muscle at a time. That's the final edge. There you go. So now you have a face, right? You have a face that you can actually connect to. And what is really interesting about this reconstruction is we can finally look at two faces of an ancestor and a descendant, right? So we can talk about, okay, well, we now have a glimpse of what Australopithecus anamensis looks like and what Australopithecus afarensis, Lucy species, look like, right? But we've seen the face of Ardipithecus ramidus. I don't know how much you could connect to that compared to these faces. But I think my next step is to actually see what the earliest representative of our genus Homo looks like. That would be very interesting, right? But for now, all we have as the earliest Homo representative is like a small mandible fragment that I showed you at about 2.8 million years ago. But could Homo have started like earlier than 2.8? Now, Woranso-Mille is really an interesting site, and as much as it has sediments older than 3.4, 3.5 million years ago, it also has sediments that are about 3 million years, 2.9 million years ago, and we've started finding some fossils from those that are not Australopithecus. I'm not going to tell you they belong to the genus Homo, because we still have to work on that. But I wouldn't be surprised if the earliest phase of the genus Homo would also come from the Woranso-Mille, adding to its list of hidden treasures of the Afar region. And I'll leave you with this beautiful